Hey everybody, welcome to this session on Cloud Launch and Learn, all about DevOps with Martin Coupland. So great to have Martin here. Everyone always provides excellent feedback about Martin's sessions, so I'm excited to be joining in for this one. If everyone could take a minute just to either scan the QR code or go to the link that's on the slides here. I've also posted it in the chat. Register for this session. You'll get access to free learning materials from Microsoft, and it'll look good for the Cloud Launch and Learn team because Microsoft kindly sponsored us, and this is good feedback to them. So with that said, I will hand you over to Martin. Martin, just quickly, do you want to take questions at the end, or do you mind if I jump in with questions and I monitor the chat? Just let me know.
Yeah, jump in with questions if some come up, but I try and leave a bit of room at the end anyway in case anyone's got any. So either way, if they come up and they're in context at the time, then
yeah,
let's go through them then, because otherwise a bit later on it might be a bit of a struggle to remember what I was talking about.
Yes.
So.
Okay, awesome. Well, I'll hand over to you. Thanks so much.
Cheers, Lisa. Yeah, so hi everyone, happy Friday, and welcome to the last in this session for November. So Series of DevOps comes to a close today. So we've gone through a number of things so far, including just a general intro to what is DevOps, and then we've been talking about culture, and we've been talking around how to progress. What you do with DevOps, how do you get to be more mature, and how do you actually achieve that, and how do you measure what that looks like? So we're going to finish off by talking about DevSecOps. So for some of you who are quite new to DevOps, and I've read a couple of comments on Twitter saying they're quite new to DevOps, and the session's been great, so it's great feedback. Thanks very much for that. I'm now going to introduce you to DevSecOps, but it's not as scary as it seems. So what we're going to be talking about in this session really is a couple of things. So we're going to be talking about why security is so important, and for a lot of people that will be like teaching you to suck eggs, and I apologize for that, but it's important to make sure that there's some groundwork in place to understand why we do this. And I also want to talk about how we actually do this within teams. So from outside of a technology perspective, I also want to talk to you about that first. And then we're going to talk about how you actually do this in Azure. So you can get a really good, secure environment built up to do all of your development and release using built-in tools that are available right out of your Azure subscription. So, please do feel free to make notes and ask lots of questions. And when it comes to that point, feel free to take screenshots or watch the recording back later. And, from there, we will basically be able to go forward and do what we need to, and hopefully show you how we can do this out of the box with no third-party tools. So first of all, let's talk a little bit about the concepts of DevOps and the theory of DevSecOps rather. So fundamentally, I'm going to go through some points, and then I'll try and explain a little bit more about what that actually means. So first of all, it's around shifting security left, okay? And shifting security left just means that we move the responsibility of highlighting and knowledge around security away from the experts in InfoSec, more towards the developers. So that's what we mean by shifting it left, but also towards our operations teams as well. So we move it as far left as possible. And some of that might sit with the support teams as well, from some of the tooling and some of the things that they have access to. Why is DevSecOps such a good thing? Why is it good to have good security practices in your DevOps pipeline? So it builds a lot of confidence in your software supply chain. So I'm not just talking about from a customer perspective, because let's face it, quite frankly, most of the time, they won't really care what happens to get your software released. They just want to consume it. But if you start to work in a B2B scenario, a business-to-business scenario, and you get questions asked about how you release software, how you identify bugs, how you stop those bugs from leaking into production, then these concepts, these processes, and these technical elements are a really good way to start to build confidence in what you're doing with any suppliers that you might have. As well, it also lets you deliver on a secure platform. So security is no good unless you have the fundamentals underneath. So from an IT perspective, what do we really mean by that? So from an IT perspective, we mean having good security hygiene on the platform directly itself. Things like being able to manage access control effectively, not giving everyone as much rights as they ask for. And also, you know, not making sure that people have the least privileged access. That's one of the most common models of security when it comes to identity and access control, making sure people don't have too much of what they need. So the whole concept of why shift left is important comes down to what I like to call the DevOps sec ratio. And pretty basically that means for every 100 engineers that you have within your organization, you may have 10 operations engineers, and then you have that one security professional. And that one security professional is the one that is really hard to find. They have deep subject knowledge in various different areas of their area of expertise around security, and they're hard to find. That means it's hard to scale. So what if we had all of those resources in one? What if we made 111 security engineers in some form or another? Now, we're not saying that this basically means that we have to go out and hire 111 security experts, but what it does mean is you should spend some time spreading knowledge and making sure that wherever possible, you are able to go as far left as possible and give those other people in your chain as much responsibility as you can in terms of making sure that they have the ability through knowledge and the means through technology or tooling to be able to highlight, identify and report security issues. Now, this is easier said than done in a lot of ways, but by shifting as much to the left as possible, you actually move your risks from a security perspective all the way left as well. And when that comes to an engineering perspective, that ultimately comes down to your source code, which is why from a source code perspective, there's then lots we can do technically around, there's lots of things we can do technically around making sure that the code is clean, conforms to quality standards, is free from known vulnerabilities and various other things. And then from a process perspective, there's lots we can do around code reviews with your peers and your colleagues and various other things that we can do as well. So this is why it's really important. And this is why a lot of organizations are starting to do this within their organization, because the ability to shift as much to the left as possible is really key to getting levels of scalability. And when it comes to security, that scalability is really, really important, because we always want to be in step with what the bad guys are trying to do. We never want to be a step behind. So now let's talk about the art of DevSecOps, right? It's okay talking about why we need to do it and how we can do it technically, but from a team structure perspective, how should you form DevSecOps? Now, this diagram tries to basically illustrate the various different roles that are really key to making sure that you have good practices of security within your organization. Now, other than very large enterprises and very large organizations, you are highly unlikely to find all of these roles being either in separate teams or separate people. Multiple people may perform these functions. Now that's okay, as long as those people have the ability to scale to what you need them to be able to do. As soon as it becomes a problem that those people are no longer able to perform those functions because they have too much work, then that is when you need to start looking at scaling the team and applying the different scaling practices when it comes to something like Agile. So you might start to implement things like squads and tribes and various different other terminologies and guilds to share that knowledge of security, and that will allow you to scale up. Those things will allow you to scale up. So let's just go left to right and have a high level look at what these look like. So on the left hand side, there's security engineering. So security engineering are really the people that take data from the wild. So when you're in an information security environment, you get lots of different vectors of information. So there are obvious things like log files. There's intelligence from the community. So Microsoft published security advisories. CVE database also has lots of advisories. And various other organizations like SANS and the Institute of Technology also produce a lot of security information for you to be able to consume. Now, it's up to your security engineering team to really take that data and start to experiment with your applications using that information. So that information for them is really key, because those are the things that are publicly available to be able to try and exploit your application. You also have an edge as a security engineer, and that edge is that you know how the application is written and what technology it's using. Put those two things together, they can start to write automation to perform tests against those environments and those applications to make sure that they are secure. And what they bring out should be going back to the engineers and the developers that build the application and build and manage the platform to be able to go fix that going forward, so it doesn't come up in another more nastier variant, i.e. someone has compromised your platform. Okay, so the next is around security operations. So a lot of organizations have a SOC of some kind, whether that's outsourced to a third party or whether they're fortunate enough to run one internally. And your security operations team are really responsible for the hunting, detecting and containing of any security threats. So what that means is they are the ones that monitor the environments for security breaches. They then look for where those breaches are happening, detect through monitoring, and then contain that within an isolated environment if at all possible. Once you have been breached as an organization, the best you can hope for is actually to contain that breach in one place rather than let it spread to multiple different environments and, worst of all, multiple different applications. It's really important to detect what is happening in your environment, be able to then hunt down where things are happening in your environment, and if you need to press a button and pull something out, contain it. And that containment can be in any number of ways. It could be severing network connectivity, it could be turning off services, it could be any number of things. And when there is a critical security incident in progress, the maintaining of service is almost secondary in this degree. Security is always and should always be the number one priority for any organization. And in fact, a great way to think about this is really, we always feel like we're a step behind the bad guys a lot of the time. There's things you hear in the press and the media. It's really important to make sure that you can really find what is happening and then really control that scenario. And one of the great sayings I heard is that for everything you can't present, anything you can't prevent, you need to monitor for, and that's really, really important. Next is around compliance operations. Now, compliance operations are your people that are responsible for responding to incidents when they happen. They're also responsible for managing those incidents. And then from the after effects or the regular ongoing day-to-day management of compliance within your organization, they are responsible for training your employees in the art of security, in the understanding of security policies that your organization has. And they're a real critical part in the chain, because they're able to break down what's happened after the incident has occurred, and then try and manage the response and manage that going forward, and also train people so it doesn't happen again. The final one is an extremely nice to have one, but it's an important one if you can do it. And this is around using tools like machine learning, if possible, and using various different forecasting tools to be able to learn from those incidents from a data perspective, feeding the data that you know led up to that incident, and then be able to measure, has it happened before and you've just not been aware of it, and then be able to forecast really exactly what might happen in the future. Is this something that people are actively exploiting? Do you actually need to be focusing any more efforts, or quite frankly, any more cash in being able to try and deal with this threat? So one of the key things to making sure that security is done effectively, and that your developers are not just dealing with huge amounts of data that they have no way of really seeing through and being able to deal with, is by employing high fidelity feedback. And this is the form of continuous improvement and continuous feedback. What it really does is take a number of different events. So if you look on the left hand side there, there's some examples of some of the sources of data that you might get some information. So we've talked about logging, we've talked about events. Someone just move the slide there. So there's a number of different events that might happen, a number of different logs, as you know. There's artificial intelligence that might bring some information there. There's also your internal tooling, penetration testing, internal and external researchers, bug bounty programs that you might offer to members of the public to highlight and report security incidents, and also your red team as well. So your red team is your internal set of hackers that are responsible for trying to penetrate and break your products. These can generate billions of events, and if you were to pass all of those billions of events to your developers to fix, they would have no idea what the priority was. They would have no idea if what they're fixing is actually a realistic threat versus something that is highly unlikely to happen, or is unlikely to happen unless a number of other conditions are met. So this is where prioritization of the information comes in. Really to start drilling down into the real tangible things that your developers need to fix, you need to start correlating that data and bringing it down to a much smaller subset and a much smaller number. So it's really important to make sure that you scale that down into, in this example, millions of events using something like correlation. We can then get down into the thousands by employing just good case management. Okay, so good case management is a really key thing around making sure, has this happened before? Do we already have a bug open for it? Employing different types of automation through your workflows and through your pipelines, so both your service management workflows and your build and release pipelines, to really, drill down to not reporting anything else that is already in action. So this is another form of correlation and almost deduplicating the data in a lot of ways, but it really starts to get those numbers down into the real tangible things that you need to think about. Once all of those things have happened from an automation perspective, we hopefully then get down to the tens, hopefully not hundreds, but in some environments it may well be hundreds. Especially for large organizations, but we want to be getting into really small numbers of things that we can deal with as developers. So if I have my development backlog, I obviously would much rather have, even 100 things which are really tangible, actionable things, actionable defects, features that need improving when it comes to security, rather than just getting raw data come in. Raw data does not help people see the wood from the trees. It's really important to make sure that you are focusing in on what matters, and prioritization with the product owners and the product teams within your organization is really what starts to drive a lot of this forward, and make sure that you are dealing with what's important rather than a huge amount of information that is frankly no good to anyone. Okay, so now we've talked about how and why, we're going to move on to enabling this on Azure as a platform. So now we've talked about some of the concepts of it and some of what it means to your organization. We're just going to move on to talking about how you can actually do this with some technology. But I just want to pause for a second and see if anyone has any questions on anything that we've talked about so far.
There's no questions in the chat.
Okay.
I don't think. Does anyone have any questions? I made a slight slip up with the Teams presenter view at one point, but we rectified that. No questions.
Okay, good. Right, let's carry on. Let's carry on now. Okay, so hopefully everyone recognizes the icons that are on here, especially if you're already a heavy or a frequent user of Azure. So obviously with Microsoft's acquisition of GitHub, that is why GitHub is now on there. And also, one of the important things to mention here is, where do you put your code? Do you put your code in Azure DevOps, or do you put it in GitHub? And you know, that's a completely different topic. In all honesty, you could quite easily replace GitHub with Azure DevOps, but there's some specific features in GitHub that I want to talk about, which makes this story a lot more fluid. And you can, of course, specify GitHub repositories as a source for your pipelines as well. They don't have to be within Azure DevOps. So first of all, when it comes to securing your code, if you think in a highly secure environment where few people have access to production environments, or few people have access to any environment really, it's really important to make sure that you secure your code. And why it's really important to secure your code is, as we move the risk of attack and risk of weakness for your applications further to the left, that risk then sits with code. So it's really important to make sure that the code that you check in is not just automatically trusted. So we can use certain features in GitHub. So GitHub Advanced Security is the feature name. It's also called CodeQL for anyone that's used it for a while. We could also use tools like Dependabot, which is in GitHub as well, which will start to identify and remediate any issues with your dependencies. So dependencies that are out of date. So these are things like NuGet packages and package repositories. It will look into those and it will check if any of them need updated and have any particular security weaknesses in. So that's a really important feature, and it's one that's really good to use. You actually need a pro account for those as well, so it's not free, but it is well worth the additional value that you would get on top of your organization. One of the other great things it will do is, without having to run a specific task in your pipeline, it will scan for secrets. And when things like IP addresses and what looks like hard-coded usernames and passwords are found, it will scan those for when they're committed to the repository, and it will flag those up for review to make sure that they are allowed. And obviously the recommendation there is to make sure they go into some kind of secret management tool. So if you're using Azure, the obvious choice there would be Azure Key Vault. If you're using some other technology, obviously HashiCorp, who write Terraform, have a HashiCorp Vault available, which does a very similar thing. And there's various other tools as well that you can use to achieve the same thing. Next is around your continuous integration delivery, so CI and CD. So the pipelines are really good. So if you're struggling with the concept of pipelines, just think of them as workflows, right? All it's doing is taking a number of tasks and automating those tasks. If you think as a developer what steps you do to be able to get source code compiled and then deployed out to an environment, that is just a set number of steps. This is just automating those set number of steps to make it more idempotent as well, meaning what we put in every single time will be what we get out if it's the same thing. So we really have the ability through other features in Azure DevOps, such as the boards feature where we manage our work, we can track bugs and all kinds of different things in there. We can track and link those to commits within repositories. So we really have full traceability, being able to track back every single commit, every single work item, and every single build artifact of every single thing that is produced. So when it comes to container images, which is what this example is, for every single image that's built, I have a full history of every single one that's built, with what commits of source code are in there, what work items it relates to, so I instantly know what new features are added in, what bugs have been fixed, all of those things. And that is just out-the-box functionality. That's just stuff that the tool does straight out the box. Next thing is around container scanning. Now, this is a great feature that Microsoft have with Azure Container Registry through some integration with Azure Security Center, meaning that when your images are uploaded to the container registry, it will use a quality scan to go off and scan those container images for vulnerabilities. And off the back of there, you'll be able to look in Security Center and look at the things that it has highlighted to be able to look at the things that you need to go off and fix. So this is a great thing that you can use. You could go a step further actually and retrieve the results of those in Security Center within your pipelines and have automation gates, which basically prevent you from going any further should a number of vulnerabilities or critical vulnerabilities be found in your container images. So you can really start to automate a lot of that monitoring and management process as well to make it a lot more fluid. And even if you wanted to, you could just fill the pipeline and log anything that it finds back as a bug into the developer's backlog, if that's what you wanted to do. AKS is in the middle here, so Azure Kubernetes Service. Excuse me. So being able to deploy to your AKS clusters directly from your pipeline and being able to utilize infrastructure as code solutions, so that could be Terraform, it could also be ARM, as well as integration with Azure policy and blueprints to ensure compliance. You can put all of these in your pipeline to make sure that what you deploy is what is trusted by the platform. And think of this as a guardrail scenario. Think of it as a pair of tracks. And you have one either side. Everything in the middle you can do absolutely fine. Everything outside is stuff that is not allowed and controlled by policy. All the pipeline is doing and all this technology is doing when it comes to policy and blueprints is making sure that you stay within those tracks and stay within what is allowed by your organization. When you do that, the solutions and deployments and releases will go all the way through as far as they can without being stopped. But these tools are really there to make sure that we capture anything before it goes to the production environment. What is also great about all of this tooling end-to-end is it doesn't stifle innovation. One of the things you'll quite often find in a lot of organizations is that with various different security policies and with various different technical means in place to protect the environment, that can have a negative effect on creativity and innovation within the teams, meaning that they can't use various tools because they're not approved, they've not been looked at from a security perspective. Being able to define your policy and your security standards by code in form of policy means that you can allow people to be more open with what they're doing and allow people to be innovative and allow people to get your organization ahead of its competitors by using the latest technology. We had a quick talk about the Key Vault right at the top of this slide. So managing your secrets, and what do we mean by secrets? Anything that has any sensitive information in there. That could be keys, it could be certificates, it could be authentication tokens for APIs, connection strings to databases that have passwords in, all of these things, any other piece of information that you would deem a secret, the application can call them at runtime. This is really, really important because it then means that from a code perspective, when you look and inspect the code, from a code level, you have no idea what that secret is. You can glean the name of the secret, but your permissions within the vault should also determine that you're not able to read them if you don't have access to do so. This also means that you can start to segregate your secrets between environments, because the variable you would use in code to be able to call your secret shouldn't really change, and the name of them shouldn't change, but the vault it connects to via a configuration item is something that will change between environments. So what is valid in development may not necessarily be valid in pre-production and also production, and there is no real way to find out unless you are authorized. One of the great ways that Key Vault helps do this as well is, even if you are an administrator of a subscription in Azure, unless you are specifically defined in that Key Vault policy to be able to list and view or create secrets, depending on what your permission structure looks like, you will not be able to access any of these items themselves. And you can use foreign principals, you can use certificates, and you can use managed identities within your applications within Azure to really start to lock this down so that only the application that is running itself, if it's, for instance, an app service or an AKS environment, has access to read those secrets and be able to get the true value. That makes it a highly secure environment, because even if your code is compromised, the attackers do not have any secrets or other pieces of sensitive information that they might need to further carry out an attack. Don't forget, for a lot of the times, hackers are around gaining intelligence. Right? They are trying to find out information about your applications and your environments to be able to hack your systems and your applications. So removing as much of that as possible gives them as little as possible, meaning that your attack surface is a lot smaller and you can start to focus your monitoring from a security perspective on exactly where it needs to be. Next thing is around authentication with Azure AD. So using Azure AD in some of its more advanced features like MFA, multi-factor authentication, some of its activity reporting, and some of its built-in technology around, for instance, making sure that when you've logged in from London, if you then log in 10 minutes later from Seattle, it will block that login and ask you to perform multi-factor authentication because the travel distance in 10 minutes is impossible. Security features like that. Security features like only being allowed to access from authorized devices. These are all things that are built into the identity plane. And identity, in my opinion, is one of the most important parts of the security life cycle and the security hygiene of your organization and your environment. And identity is really key to making sure that not only authorized people have access to any applications that they need to be authorized to, but also they have the roles that they are allowed to perform. So that's through authentication and authorization. Next thing is around telemetry. So there's a good old saying which works in many different walks of life, and especially this one, is you don't know what you don't know. So being able to know information about your environment and collect that detailed level of telemetry in as near real time as possible is really, really important when it comes to making decisions. You can make better informed decisions when you have the best data available. Anything else that you try and do on that score really is amount to a lot of guesswork in a lot of ways. So using tools like Azure Monitor and using data from things like application insights, you are able to monitor both the infrastructure and your applications in close to real time. Then using your pipelines, you can use automatic approval through quality gates. If you start to flag up something that is not right in your monitoring, that monitoring and that quality gate feedback can then tell your pipeline to roll back the release based on monitoring to the last known good image of your container. That's using a combination of technology in Kubernetes, some of its self-healing features, a lot of the telemetry that we're gathering here, and a lot of work on the back end by Microsoft's product teams to be able to stitch all of this information together. You can fairly simply, using a few different configuration values and some integration of these different tools in your pipeline, automatically roll back based on performance issues that happen as part of a release, security issues that are detected as part of a release, and anything else that looks like an anomaly to your monitoring data can actually signal the intent to then roll back. All of that information will be there for your engineers and your developers to look at, ingest, and figure out what went wrong and try to release again. Why that's important is I don't have the exact statistic here, but I read some research a while ago when I made this deck, and what it actually said was that over 85% of security breaches in in-house applications are done within 10 minutes of a new release going out. So what that means is that one of the weakest points of your application is when eyes are on different things because you've released a new version of your application. Eyes are on making sure that users are able to use the application properly, making sure you're not getting exceptions that you shouldn't be, making sure any ancillary services such as third-party APIs or anything like that are all working as they should because of your new release. So fundamentally, when your guard is down due to a release, that is when your application can be the most vulnerable. So imagine what impact automation has on that process. With trusted automation, intelligent automation in a lot of ways, that can mean that you get to the point where you are able to then basically trust that process implicitly. And like we said right at the top, improve your confidence in your security to be able to release with confidence. And that is a really key thing. Knowing that you can release something on demand and have all bases covered from a security perspective. And for those unknowns that you don't have covered, you have security monitoring in place that will detect those things. Is really critical to most organizations today with the increased number of cyber threats that are out there. So all of this stuff is really, really good, right? But I wanted to add a little bit of information from some of the teams that I've previously worked with, both where I am at the minute and Sonar and my previous organization as well. So where I've worked with teams that have a particular focus on security testing, detecting and measurement of progress, they have reported 30% fewer defects that have gone through to production. So as an organization, if you are tracking defect escape rate, this is a 30% decrease on your metric that you are reporting on. The MTTR, mean time to recovery, is 5 times faster than the teams that are not working to the same standards. MTTR is a great metric because it measures the time it takes for you on average to recover an application to it being fully working from when that system was detected as being down. So the lower your MTTR, the better you are at identifying and recovering service as quickly as possible. So MTTR is a really great metric in a lot of ways. Next one to highlight here is the average success of continuous integration and deployment pipelines. So the teams that I did this with, and when I built the slides and collected the data on here, the average was an 98% success. So 98% of the time, their pipelines are succeeding. That gives me a clear message, and that clear message is that the work we've done around transferring knowledge and transferring some security responsibility to these teams has fundamentally worked. Because we have those automated checks and balances in along the way to make sure that we pick up some of the things that they were doing before, leaving secrets in source code, leaving IP addresses in, running vulnerability scans. So the knowledge that has been passed down to these teams that are writing and running these applications has had a huge impact on the success of build and release pipelines. And that's a really good sort of side metric to highlight, is that on the face of it, you would say, great, my teams are now able to build and release more successfully than they were before. But when you look into what that actually means, because of the gates and the quality control that you have on that process, that is actually telling you that people are listening to what you're saying and people have improved because of the work that you have already put in. Okay, so as we start to wrap up, there's 5 key takeaways that I want people to take from this session and this series, really. So this is a combination of 5 really key things from the last 4 weeks that I have had the pleasure of presenting. So first one is around where you measure. Okay, so obviously measure at a team level because that allows you to then roll up to a global or an organization level. But measuring individual teams will start to bring back some of that siloed thinking that you have avoided as part of Agile and DevOps already. Security's goal is to fundamentally help the business achieve the goals that they have set out to do. And they are letting you do that or enabling you to do that in a secure manner. They are not there to block what you are doing. You are blocked from what you're doing from a security standpoint because it's not secure or doesn't meet the corporate standards. That is why security exists. It's to prevent mistakes. Next thing is around measuring outcomes via outputs. And I talked in a previous session around this a little bit and around measuring work and that not being tied to specific outcomes or tangible outputs. Now, it's a really interesting one, really. So the key thing is understanding the difference between outcomes and outputs. Okay, so when we talk about outcomes, those are actually what the business wants or what the business needs to achieve. The outputs are the actions or items that contribute to achieving that overall outcome. So you need to make sure that you're measuring both, in other words. Don't just measure one or the other, make sure that you're measuring both is a real key thing. Next thing is around maturity threshold. So when we talk about maturity, so it's important to measure maturity. So I'm not saying don't measure maturity, but too many teams put a strong focus on attaining a certain level of maturity. You know, the simple message here is don't do that. Prioritize the resiliency of your team over an overall notion of maturity. Maturity is great, but maturity only tells part of the story. Okay, so don't focus on it too much. It's important, but it is not the number one thing from getting you to being a good DevOps team to a great DevOps team. Next one is around don't miss the forest for the trees. We actually touched on this a little bit earlier on, but it's very easy to do, and it's arguably easier to do when you are working in set product teams within an organization that only focus on certain things. Focusing on components too much rather than the bigger picture means that bigger picture can be missed, is the fundamental message there. So while you're working on your small area, don't forget to look up and look at the forest is basically the message there. Don't forget to look at that bigger picture. And if we are working in things like squads and tribes within our organizations, this is where other things like chapters, which are already experts within the various squads within tribes, or your guilds that sit across organizations, those chapters and those guilds are really the glue that sticks your organization together and means that knowledge is transferred between all of the subject matter experts within the organization so that when they go back to their specific teams, they are implementing and working to the best practice. If you don't do things like that and make sure that knowledge is spread out to the people it needs to be spread to, you may as well be, if your team has 13 agile teams, you may as well be 13 different organizations. And so just to reiterate, it is those things called chapters and guilds, and there's plenty out there on the internet about what they mean and how they work in agile. They help with scalability, but they are also the glue that holds your organization together. They are the glue that means that all of your architects, all of your security engineers, all your DevOps engineers all work to the same standards regardless of what team they are in and don't do their own thing. Okay, so the next one is potentially slightly controversial. Okay, so this is don't try to measure failure. Okay, failure is inevitable. So therefore, incentivizing the avoidance of failure is an unrealistic metric to measure. Great example I have of this is lots of organizations measure SLAs, but organizations still measure SLAs in the same way they did many years ago, and that is around availability or a certain metric being hit a percentage of the time. In a lot of organizations, especially those that are using third parties or cloud providers, those are not in your control, right? What happens on those environments is often not within your control. So your organization setting an SLA for availability of your application is an unrealistic thing to measure because there is not much that you can do about that failure. We are best measuring things like mean time to recovery. Metrics like that are more meaningful because it gives you an idea of how long those applications were down for. And that is a more striking metric for me in a lot of ways in the modern cloud native world than measuring availability of a platform, because availability doesn't always tell the whole story. Okay, so just for tech questions, so I definitely just want to say thank you to the Cloud Lunch and Learn team for letting me spread my dulcet tones for 4 weeks. So thank you to Lisa, and thank you to Dana, who moderated the other sessions that we had, and Hugo and the rest of the team for putting on these great events. They have much more to come. You can go check out their website, cloudlunchandlearn.com. They have some great speakers, and they have some great sessions on things like serverless and security coming up, so definitely make sure that you check out those. And then last is, I recognize a lot of the names on here from the past 4 weeks. A lot of you have attended every single one, so thank you very much for everyone taking an hour out of their precious day to come and listen to me bang on about DevOps for 4 weeks. It is highly appreciated. And you can obviously find me on Twitter if you would like to as well. So my Twitter handle is Mr. Coops, Coups. You can also check out my blog as well for more ramblings on DevOps and Azure. So you will find that at m12d.com. Long story in there. So with that note, and before we end the call, if anyone has any questions, feel free to ask away by chat, or feel free to come off mute if you would like to and ask any questions. Alternatively, you can find me on Twitter and ask any questions directly on there as well. So I will just put up this slide again. If anyone's missed doing that, don't forget to get some of your free resources.
Yeah. So guys, I popped a few links in the chat. Sorry to bombard you, but there is a link that matches this slide, so you can register for the session and get the resources. There's also a feedback form. So if you've enjoyed this session, which I am sure that you have, please take the time to fill in the feedback form. It really means a lot to us, the team at CLL, and also our speakers. And then I've put in the next up and coming sessions. I've dropped the links in there if you want to register. In terms of questions, like Martin says, if anyone has any, jump off mute. I can see something in the chat here, so 2 seconds. So apologies if this was mentioned previously. A lot of talk about how important it is to measure metrics. Do you have any recommendations of places to go to find out more info on that, about what metrics we should be measuring? And also how to measure?
Yeah, so it's a good question. So we did talk about it, but that's absolutely fine. There's absolutely no harm in repeating it. So if you search for 15 metrics for DevOps success on a website called Stackify, they have a great list of 50 metrics that are commonly measured in DevOps to measure success. How to measure them obviously depends on the metric, right? So if it's something like deployment time, then you're simply measuring how long it takes to deploy something. If you're measuring something like defect escape rate, you are obviously measuring how many defects make it to production. Yeah, that's the one. Thanks, Lisa. So that's a great link, right? So that's got examples of things that you can measure. As the article title suggests, there are 15 on there, and they cover everything from velocity of the team all the way through to quality and performance as well. So those are the three main areas that you really want to be looking at when it comes to metrics.
Awesome. Thanks, Martin. Does anyone else have any questions that they'd like to ask?
Great.
Lots of people saying thank you, Martin, and everyone saying that it was really helpful and they've really enjoyed the series, so that's good.
Yeah, cool. Well, like I say, thank you everyone to joining. Appreciate it. It's an hour out of everyone's day. So yeah, thanks very much, and hopefully see you all again at some point in the future.
Awesome. Thanks again, Martin. Much appreciated.
No worries.
Thanks everyone for joining.
Cheers, everyone.